Hello all, welcome to my YouTube channel. Now we are going to do methods of preparation of alkynes from the chapter alkynes. In that we have total 5 reactions. The first reaction is by the action of water on calcium carbide. Second one by dehydrohalogenation of dihaloalkanes. Number 3 is by dehalogenation of tetrahalides. Number 4 is by dehalogenation of haloforms. And the last reaction, that is fifth, is by Kolb's electrolytic reaction. Now we will go to the first reaction, that is by the action of water on calcium carbide. So in this, we will go to the reaction. Okay, so by the action of water on calcium carbide. So calcium carbide is carbon, triple bond carbon. To that, we are going to attach calcium. So this is our calcium carbide. That is CaC2. Calcium carbide, it reacts with two molecules of water. Two molecules of water. So we are going to write down as HOH and the second HOH. So this reaction takes place in both laboratory as well as it can be used on commercial scale. So you can write down both these words on the arrow. So calcium carbide reacts with water molecule to form alkynes. So you're going to see that you have this calcium and you have two hydroxyls, OH. They will be removed as calcium hydroxide, CaOH twice as a byproduct. Whatever is remaining, that is carbon, triple bond carbon, and two hydrogen atoms, they club together to form C triple bond C and two hydrogen atoms on two carbon atoms. So this is our acetylene, or the IUPAC name is ethine. YNE. Okay, so this is our first reaction. Now we will go to the second reaction, that is by dehydrohalogenation of dihaloalkanes. Now this reaction, it is going to take place in two steps. So coming to the step number 1. So step 1, so step number 1. So in this we are going to take our starting material, that is 1,2-dibromoethane. So 1,2-dibromoethane means you're going to write down two carbon atoms to satisfy the two carbon atoms with Br. Okay, so two Brs, they are written on the carbon atoms and the remainder of the hydrogen atoms. Okay, so this is our starting material, that is 1,2-dibromoethane. It is going to react with potassium hydroxide. We are going to take alcoholic potassium hydroxide. Okay, so see what is going to happen. In step number 1, Br from, say, first carbon atom and hydrogen from the second carbon atom. Okay, and potassium from KOH. So potassium and Br, it will be removed as a byproduct, that is KBr, that is potassium bromide. and hydrogen from the second carbon atom and hydroxyl group from the potassium hydroxide. It will be removed as water molecule. Okay, so these are our byproducts, KBr and water molecule. Whatever is remaining that you're going to club together. So you have CH2, as we have removed Br. So there is going to be introduction of a double bond and formation of CHBr. The name of this first product is 1-bromoethene. Okay, ethene because it is an alkene. Coming to step number 2. So in step number 2, we are going to take the product from step number 1. So first write down step 2. So take the product from step number 1, that is 1-bromoethene, that is CH2 double bond CHPr. React it with second molecule of potassium hydroxide, which is alcoholic. Okay, give an arrow. Now the same thing is going to repeat. So you have potassium and you have Br. It will be removed. So the byproduct is KBr. Okay, the same product, the same byproduct now you have, that is OH and hydrogen from CH2. One of the hydrogen will be removed. So what is remaining? You have CH triple bond CH. Okay, as we have removed one molecule of water. So this is our final product, that is ethyne, that is acetylene. Okay, so look at the reaction. So we have step number 1. We have started with 1,2-dibromoethane. It reacts with alcoholic potassium hydroxide. Remove Br, react it with potassium to form the byproduct, that is KBr. Then you have hydroxyl group from alcoholic KOH and hydrogen from the 1,2-dibromoethane. Remove it in the form of water molecule and form 1-bromoethene. Then take 1-bromoethene from step number 1 and react it with the second molecule of potassium hydroxide. Again remove the same two byproducts, that is KBr and water molecule, and our final ethyne will be formed. Come to the third reaction, that is by dehalogenation of tetrahalides. Okay, now for dehalogenation of tetrahalides, we are going to take again our starting material. Okay, so our starting material for this reaction is 1,1,2,2 tetrabromoethane. Okay, so we are saying it as ethane. So you are going to write down ethane, 2 carbon atoms. Okay, so 1,1-dibromo. Sorry, 1,1 2 2, sorry, 1,1,2,2 tetrabromo ethane. Okay, so we have written 4 carbon atoms, 4 bromo atoms on 2 carbon atoms. It is going to react with zinc. The zinc, it is in the dust form. Write down the name of the starting material, 1,1,2,2 tetrabromo ethane. It reacts with zinc dust This reaction takes place in heat and in presence of methanol, CH3OH. Now you can see you have zinc. You have two molecules of zinc which react together. Now zinc, it is going to react with Br. So you have total of 4 Br. So zinc and Br togetherly, they will be removed at as ZnBr2. Okay, so these are the two molecules of ZnBr2. Whatever will be remaining, that is CH triple bond CH, that is your ethyne, that is your acetylene. So this was our third reaction by dehalogenation of tetrahalides. Come to the fourth reaction, that is by dehalogenation of haloforms. Now haloforms are chloroform, iodoform, likewise. Now we are going to take chloroform. Okay, so first write down the structure for chloroform. Okay, so chloroform, it is CHCl3. So write down carbon. So you have CH and Cl. Okay, so this is the first molecule of chloroform. Okay, now this chloroform, it is going to react with silver. You're going to take 6 Ag, and again it is going to react with chloroform. So instead of writing 2 CHCl3, we are going to write down the two structures of chloroform. Okay, so again this is the chloroform. Okay, so this is the second molecule of chloroform. So this is our second chloroform. Okay, now look at the structure for chloroform. So you have first Cl, second, third, then you have fourth, fifth, and sixth. Okay, so 6Cl and you have 6Ag, which will be removed as 6 silver chloride, 6AgCl, and the remainder is our ethyne, that is ETHYNE, that is acetylene. Okay, so this was by dehalogenation of haloforms. Now coming to the last reaction, that is by Kolb's electrolytic reaction. Okay, now in Kolb's electrolytic reaction, we are going to start with the potassium salt of malic acid. Now how this potassium salt of malic acid is written? So you are going to write down CH, double bond CH, and satisfy the last bond with COOK. COOK. So this is potassium salt of malic acid. Write down the name, potassium salt of malic acid. It reacts with two molecules of water. So you have HOH and the second HOH. Now as it is electrolytic reaction, you're going to have products that are formed at cathode and anode. Now if you look at the starting material, that is potassium salt of malic acid, you can look, you have potassium, you have two potassiums, okay, and you have two hydroxyl groups. So potassium and hydroxyl groups, they react together to form KOH. So you have two potassium hydroxides. Then you have two hydrogens. Okay, so they are going to evolve as hydrogen gas. Okay, so these two, they take place at cathode. Okay, so it takes place at cathode. Now at the anode, when you look again at the starting material, you have COO and the second COO. So you have evolution of carbon dioxide. Now whatever is remaining, that is our product. That is carbon, triple bond carbon, satisfy it with hydrogen atoms. That is our ethyne. Okay, and this it is entirely at anode. Okay, so with this we complete with the five reactions of methods of preparation of alkynes. Okay, now we will quickly see what we have completed. We have seen five methods of preparation of alkynes. Coming to the first one, that is by the action of water on calcium carbide. So write down the structure for calcium carbide, that is C triple bond C, attach it with calcium atom, then react it with two molecules of water, remove calcium hydroxide as a byproduct, remainder it is acetylene or ethyne. Second method is by dehydrohalogenation of dihaloalkanes. As we are saying it as dehydro and dehalo. So you're going to write down dehydro, that is removal of water, and dehalo, it is removal of potassium bromide. Write down in two steps. Step number one, it is you're going to take the starting material, that is 1,2-dibromoethane, reacted with first molecule of potassium hydroxide, which is alcoholic, remove KBr, remove water molecule and form ethene, that is 1-bromoethane. Step number two, take the product that is formed in step number one, react it with second molecule of potassium hydroxide, remove again potassium bromide and water molecule to form ethyne. Coming to the third reaction, that is by dehalogenation of tetrahalides, take 1122 tetrabromoethane, react it with zinc dust, remove byproduct that is ZnBr2, and the remaining it is ethyne. This reaction it takes place in presence of methanol. Coming to the fourth reaction, that is by dehalogenation of haloforms, take two molecules of chloroform and takes 6 Ag. Remove 6 Ag in the form of 6 silver chloride, that is 6 AgCl. Remainder is ethyne. And the last reaction, that is by Kolb's electrolytic reaction. In this, you are going to take potassium salt of malic acid, react it with two molecules of water. Then you're going to form acetylene and carbon dioxide at anode and potassium hydroxide and evolution of hydrogen gas at cathode. With this, we complete with methods of preparation of alkynes. So for more videos on chemistry, hit the bell icon and subscribe to the channel. Thank you.